All right, let's work on this example, 18.4. Evaluate the integral of e to the x squared plus y squared over the upper half of the unit ball. So this is a function from R2 to R. So when I say unit ball, I just mean the unit sphere in 2 dimensions. And I only care about the upper half of it. So -1 to 1. It's over this region that I want to integrate this exponential function. All right, so where's my theta? My theta is running from 0 all the way to pi. Now the integral in the radius, where's my radius going to run from? The smallest radius I have is 0. And the biggest radius I have is 1. All right, now I want to integrate this function. So I have e to the x squared plus y squared times an r. So I guess this is kind of bad notation because I have a mixture here, Cartesian and polar coordinates. I need to replace that x squared plus y squared with r's and thetas. So I'm going to write this as the integral from 0 to pi, the integral from 0 to 1, e to the r, because x squared plus y squared, r squared. X squared plus y squared is the radius squared, right? With the observation that x is equal to r cosine theta and y is equal to r sine theta. All right, and then I have an r dr d theta. All right, let's run through this. After we integrate our first integral, the inside one, we'll leave the outside integral alone, and we end up with a 1/2 e to the r squared. We're able to actually do that integral with a u substitution because we have that r sitting right there. All right, let u be r squared, then du would be 2r, which is why we divide by that 2 on the outside. And this will be evaluated between r is equal to 0, r is equal to 1, with our d theta on the outside. And when we actually perform the first integral, we end up with 1/2 times e minus 1. And then we integrate in theta, and we end up with a pi over 2 times an e minus 1, because when we evaluate this at theta is equal to 0, we just get a 0. So it's really just this integrand at the upper bound. Cool. So this is a real number. You can approximate it if you want to, but that is the value of this function here, or it's the volume underneath that function over the upper half of the unit ball.